So in this video we're going to be looking at how to solve simultaneous equations containing a quadratic and a linear equation. So this is only for the higher GCSE minions and above. So if you're a foundation minion and you found yourself here, by all means feel free to stick around and play with us, but you really don't need to. Okay, so first of all, what is it that we are doing when we're solving these simultaneous equations? Either we'll have the standard quadratic parabola and we are looking for the intersection points of a straight line with the curve, or we can also be playing around with circles as well, but we'll have a look at that in a moment. So we've got two possibilities with the quadratic curve. Either the line will be a tangent, as here on the left. If the line is a tangent, then there is only one single point of intersection between the line and the curve, so we'll be finding one value of x and one value of y. Or if the line is not a tangent, then there will be two intersection points and we need to find two values of x and both their corresponding values of y. Now you might be thinking about what happens if a line doesn't meet a curve, which it does happen, good question. If that's the case, then we're not dealing with simultaneous equations because there would be no real solution to them. So we're only dealing with these two possible scenarios, as well as the two with the circles. So another common sort of question I like to ask you about at GCSE is a straight line meeting a circle centred at the origin. So again, really, we've still got the same two situations, except the quadratic equation will be a little bit different. X squared plus y squared will equal the radius squared. Standard equation of a circle centred at the origin. Now we've got our two situations. We've either got the tangent again meeting the circle, and there will only be one set of coordinates, one x and one y value, or the line won't be a tangent and there will be two sets of coordinates, so two values of y and two values of x. Now before we get going, I want to talk a little bit about substitution and how it works. I find very often people find it difficult to comprehend what an equal sign is actually telling us. So, using a real life example here, I'm sure we're all familiar with the fact that a £5 note has exactly the same value as 5 £1 coins. Just the same as 5 £1 coins has exactly the same value as a £5 note. Then, if we algebra this up a little bit and we call our £5 note y, and we call a single pound coin x, then algebraically we can say that y is equal to 5x, or just the same, we can say 5x is equal to 1y. Now sometimes it's going to make sense for us to use our pound coins, sometimes it's going to make sense for us to use our notes. So what we do, we either substitute the coins in where there was a note, or vice versa. Now if that analogy is helpful to you, carry on thinking about it like that. If you prefer to think about it just algebraically, keep thinking about it algebraically. So the aim of substitution is the same aim as with elimination. It's to eliminate one of the variables. So either eliminate x or y and get yourself an equation in terms of strictly one variable. Or if you're enjoying the notes and coins, we want to get an equation that's strictly in terms of notes or strictly in terms of the coins. So once we've got an equation in terms of one variable, we can then solve that equation to find the values of that variable and then use those values to work out the values of the other variable, the second variable. So if we know the values of x, we can then use those to work out the values of y. Now as always, the best way to demonstrate this is by doing. So with these two simultaneous equations here, y equals 2x squared plus 8x minus 7 and y equals x minus 3. We can use substitution to solve these. I have also pointed out we could also use elimination. However, we are playing with substitution in this video, so we're going to do this using substitution. Now, the first thing I would recommend doing, as always, label your equations 1 and 2. Just makes it easier to say later on what you're doing with your equations. So, how do we do our substitution then? Well, again, we could actually, in this one, we could use either equation to obtain our substitution, but we usually use the linear one. There are questions where we can't really use the quadratic one, and we have to use the linear one. So it's good practice, let's always use the linear one. So, the linear equation is y equals x minus 3. And that, in fact, is already set up in a really useful way. Straight away, it tells us what y is in terms of x. Y is equal to x minus 3. So, x minus 3 is also equal to y. So what we can do with that is substitute that into equation 1. So wherever there's a y in equation 1, we can now call it x minus 3, because we know the two things are exactly equal. It's like substituting £5 coins for a £5 note. The two things are exactly equal. They are just in a different form. So if we make that substitution, we then get left with x minus 3 equals 2x squared plus 8x minus 7. So now we're happy because we've got an equation strictly in terms of x, which we can now solve, which is pretty groovy. So what we've got going on, the highest power of x in our equation is 2. So that tells us we're playing with a quadratic equation. So we need to solve him. Let's have a look at how we do that. So, to solve a quadratic equation, we need everything to be on the same side together with a nice big fat 0 on the other side. So, first of all, then, we're going to move the x and the minus 3 over to the right. So, we're going to add the 3 and subtract the x. Now, that's going to leave us with 0 on the left equals 2x squared plus 7x minus 4. Now, I'm much happier when I've got my 0 on the right. If you don't need to be that picky, don't worry about this step. I always think it's nicer though to have the 0 on the right. So I've just switched sides. Again, remember we can do that because the two things are exactly equal. It doesn't matter which way we say that they are equal. £5 is equal to £5 coins. £5 coins is equal to a £5 note. Okay, so then we want to factorise the quadratic. If you're shaky on that at all, check out my video on it. And then once we've factorised, we can solve the quadratic and get our two values. So remember what happens here, the values swap. How did I get x equals a half from 2x minus 1? Well, remember that what we're finding is the solution, the value of x, that would make each bracket equal to 0. So if 2x minus 1 was equal to 0, we would add the 1, we'd get 2x equals 1, and so x equals 1/2. Now you might be tempted there to write that as a decimal, 0.5. You wouldn't be wrong to, but the higher up you get in maths, you will learn more and more. Fractions are your friends, but it really doesn't matter. If you prefer to use a decimal, use a decimal. Okay, so now we know our two values of x are 1/2 and minus 4. So we found the x coordinates of intersection with this straight line and the quadratic. Now for each of those values, for x, we need to find their corresponding y value, the y coordinate. So we can use either of the two equations. We're going to use equation 2, which remember was y equals x minus 3. And we're going to use that equation now with our x values to work out the two y values. So when x equals 1/2, y is equal to 1/2 minus 3, which is minus 5/2. Again, if you were playing with decimals, that's minus 2.5. And when x is minus 4, y is equal to minus 4 minus 3, which is minus 7. So there we go, we have our two solutions as coordinates. We've got 1/2 minus 5/2 and minus 4 minus 7. Those are our two solutions to those two simultaneous equations. Okay, let's take a look at another pair then. So this time we're going to be looking at a circle and a straight line. So I'm going to start off by calling my equations 1 and 2. Always a good idea. Now then, the quadratic one is equation 1. It's an equation of a circle. And our linear one is equation 2. Now we can't do anything to equation 2 nicely to obtain the same amount of the same letter. It involves squaring. Everything's going to get messy and quite scary. We don't really want to do that. So we're going to use substitution. Now we've got an extra little step here that we need to plonk in. Because the linear equation is not built to give us our substitution straight away. So we do need to do a tiny little bit of algebra. And what we need to do, we need to get an equation for one of the letters in terms of the other. So I would go for adding the 2x, and then that would give us y equals 2x plus 5. Now I'm going to call that equation 3. So now we know what y is in terms of x. Y is equal to 2x plus 5. 2x plus 5 is equal to y. So now we go to equation 1 and use that substitution. So the y is going to become 2x plus 5. So we're going to get x squared plus 2x plus 5 all squared, and that's going to equal 25. Now we need to expand that bracket. What we've got here again, before we go any further, we've got ourselves a quadratic equation. We know this because the highest power of x hanging out is 2. So we need to expand this bracket, simplify the algebra as much as possible, get everything on the same side, and then solve this quadratic for x. So if we expand this bracket, we're going to get x squared plus, now the expansion is going to be 4x squared plus 20x plus 25, and that's going to equal 25 on the right. If you're at all shaky with doing that expansion, check out my video on quadratic expansions. Now if we simplify this, we've got 1x squared and 4x squared, so we've got 5x squared, add 20x, add 25 equals 25. Now that might look quite scary as it stands. Got a quadratic that doesn't have a single x squared, they're always quite tricky. However, before we start to panic and think about using the quadratic equation, let's see if we can simplify this down at all. So first of all, it's quite nice that we've got a positive 25 on both sides. We can take that away, which is tasty. Then that's going to give us 5x squared plus 20x equals 0. So already that looks probably quite a bit more simple. Now we've also got this common factor of 5 running through. We do also have a common factor of x. However, if we were to divide that away, we could easily forget one of our solutions. So don't divide the x away, but certainly divide the 5 away. So if we divide both sides by 5, we would get a single x squared, add 4x is equal to 0. Okay, so hopefully again, that's looking quite nice. So we do have this common factor of x, as I said. So instead of dividing it away now, instead let's factorize this. Like I said, if we divide the x away, we're going to miss one of our solutions, and we'll miss our marks, which is never a good thing. But we can factorize this expression on the left because of this common factor of x. We could say that we've got x lots of x plus 4 equal 0. Now we're set up to get our two x values. So x is either going to be, it could be 0, this chap on the outside of the bracket. If that x was 0, we would get 0 times the bracket, which would be 0. So that's one of our solutions, x is equal to 0, or x could also be minus 4. And that would 0 the bracket. So now we've got our two x solutions. We want to now use those to find the two y values. So remember, we've certainly got an easier equation here to use, which was equation 3, y equals 2x plus 5. So let's see what happens if we substitute in our values. So 2y equals 2x plus 5. So remember, x was equal to 0 and x is equal to minus 4. So when x is 0, y is going to equal 2 times 0 plus 5, and 2 times 0 is 0 plus 5 will give us 5. So one of our coordinates, one of our pairs of coordinates is going to be 0, 5. Then when x is equal to minus 4, y is going to equal 2 times minus 4 plus 5. Now 2 times minus 4 is going to give us minus 8, and then plus the 5 is going to give us minus 3. Okay guys, so the second solution there would be minus 4 minus 3. So our two solutions in coordinate form to those two simultaneous equations are 0, 5 and minus 4 minus 3. Okay guys, final example in this video then, so we're going to check out another circle and a straight line. So we're going to start off labelling the equations 1 and 2 as always, and we need to obtain a substitution from the linear equation to substitute into the quadratic, which here again is a circle. So the linear equation is equation 2, and again we need to do a bit of jiggery-pokery to get an equation for y in terms of x, and what we're going to do is add the x, and that will give us y equals x plus 3, and we're going to call that equation 3. So now we know what y is in terms of x, we can use that substitution in equation 1, and then we'll have an equation purely in terms of x that we can solve. Groovy. So if we make this substitution, equation 1 is going to become x squared plus x plus 3 squared, and that's going to equal 29. So the y in equation 1 has become x plus 3. So now if we expand that bracket, the left hand side is going to be x squared plus x squared plus 6x plus 9, and that's all going to equal 29. Again, if expanding that bracket was at all a mystery, check out my video on quadratic expansions, and hopefully it will clear it up. So now if we simplify the left hand side, we've got 2x squareds, we've got a 6x, and we've got a 9, and that's all equal to 29. So we're playing with a quadratic again, so we need everything to be on the same side together, and a 0 on the other side. So let's take away that 29. Then we'll be left with 2x squared plus 6x. Now 9 minus 29 is going to give us minus 20 equals 0. Now as it stands, that doesn't really look that nice. However, when you get to this point, do check if you can do anything to make life a little bit easier for yourself. So to do that, we'd want to know here, do we have a common factor running through? And in fact, yes we do. Everything is even here, so that means we've got a common factor of 2. and a 0 on the right hand side. So we can divide that 2 away, making our life much simpler. So if we divide everything by 2, we're going to be left with x squared plus 3x minus 10, and that's going to equal 0. Okay, so we've got our quadratic in x in its simplest terms, in its simplest form. We now need to factorise and solve it. So if we factorise this bad boy, we're going to get a double set of brackets. Now our two numbers need to multiply to minus 10 and add together to 3. So we are going to have x plus 5 and x minus 2. And then if that's equal to 0, that tells us x is equal to minus 5 and x is equal to positive 2. So here we've got our two x values. We now want to substitute those into one of the equations. Again, there's certainly a simpler one to choose to work out our corresponding y values. So we'll take a look at how to do that. So the equation that we're going to use, equation 3 there, so y equals x plus 3, because that's set up to tell us exactly what y is when we know what x is. Okay, so we're going to use y equals x plus 3, and x was equal to minus 5, and x was equal to positive 2. So, when x is minus 5, y will equal minus 5 plus 3, which is going to give us minus 2. So our coordinate solution there will be minus 5 minus 2. And when x is equal to 2, y will equal 2 plus 3, which will be 5. So our coordinate solution there then will be 2, 5. And that's the job done, guys. Hope you found it useful. Don't forget to subscribe. Cheers, guys.